Malaysia Green Building Council, also known as Malaysia GBC, is an organization that promotes green building programs, technologies, and design practices, aims to make Malaysia an eco-friendly and sustainability place on Earth. Malaysia GBC was founded in May 2009 by a group of passionate building consultants, academia, and representatives. Even since Malaysia's building has increased, the efficiency of resources used in each building was built with green in mind. Malaysia GBC is also supported and associated with most of the top industry institutions. In the year 2015, Malaysia GBC became an established member of the World Green Building Council and known to be the only organization in Malaysia to be supported by the World GBC. Malaysia GBC continues to be the platform that networks, promotes, educates, and most importantly, develops the sustainable, built into the land of Malaysia. With much more passionate industry professionals, we can make Malaysia a greener and better place on Earth.
Good morning, ladies and gentlemen. It is my honor to be the moderator for this session. I'm Dr. Sujata Wani, the Committee of Malaysia Green Building Council. Malaysia Green Building Council is a non-profit organization that promotes green building and sustainability. We are looking for greener industrial partner and player like you to join us to grow the green economy. Today, I would like to welcome Mr. James Ng, the Business Development Manager from NS BlueScope Lysat Malaysia, to talk about steel, sustainable construction material in a modern urban development. Today's session will be recorded and uploaded to the virtual platform and will be available till end of this year. Please feel free to type in the questions that you would like to ask the speaker in the chat box below, and we will address all the questions during question and answer session. I would like to welcome Mr. James Ng for his talk.
Hi, morning everyone. Thank you, moderator, for your welcome speech. Okay, today my sharing will be mainly on how actually steel is sustainable construction material in a modern urban development. Okay, these are the four contents, okay, that I'm going to share. Steel application in the construction, how far that we involve. Okay, second will be the context about how much that we adopt the steel in our development. Third, okay, will be more sustainable urban development. Fourth, steel application towards smart city development. Then I will share some of the case study, how actually Malaysia actually going to this direction. Okay, first, steel application in the construction, how far that we actually can change, already changed from last time until now. Okay, from 1950s, okay, last time actually we actually more or less actually using steel in more onto the infrastructure. Okay, then from there, from 1990s, it start the building development start to entry involving all the steel structure into the building. So, and now actually we are using more and more steel in the industry. Okay, but one of the example will be like the Beijing National Stadium, the bird nest, people call it as. Second will be the skyscraper, and the Empire State. It construct the building using 6 months only by using all the steel material, all the steel structure up, including the structure decking. Okay, and you can see nowadays a lot of residential, a lot of commercial building, they started to use steel material as a roofing, as a steel structure member, and more or less actually more and more steel will be coming up soon. For the next topic, we'll be talking about how much that we adopt steel in our development. Okay. In the olden days generation, you can see actually more in the kampong traditional. Okay, the corrugated metal roof only can be used. Then after that, we're using those timber truss. timber door frame, and so on. And now the modern generation, we have changed everything into steel material. The reason why we are actually involving in changing this steel material is because first, when using steel, you have certain advantages, which is the termite advantages. You have anti-termites, okay? So in steel material, you can use it in trusses, steel framing, floor decking, louvettes, fencing, door frame, ceiling, facade, and so on. Steel application, okay, in sustainable development. Okay, steel is one of the material that can be recycled and contribute in sustainable development. Okay, such as started it roll from out. Then after that, due to the come to the construction, the service of lifespan still actually lasts longer. Then from there, actually for the end of life, actually when once it's dismantled, it can be reused and recycled again. Okay. Okay, the advantage of using steel basically is actually lighter. Okay, compared with concrete roof tiles, it's actually 9 times lighter than the concrete roof tiles. First, you have a higher strength, then improve on the tensile and production innovation. Okay. Third, you have a better transport efficiency. Okay. Fourth, it can be actually pre-cut and in factory and bring to the site. So it will be less wastages and actually less construction time consumed. Okay, and cleaner on the site. Fifth will be the interference of surrounding area, less heavy equipment to hoist up the trusses and the rest of the steel material, and actually less landscaping costs also. Okay, steel for sustainable development at the service of lifespan stage. Okay, how long does it can last? Longer lifespan with current coating and latest technology from zinc, alu zinc, and magnesium alu zinc. So from last time they are using zinc, then from there they actually add in certain aluminum and zinc into the coating, we call it as a zinc. Then now in the modern design technology, now we are actually using magnesium, aluminum, and zinc coating together. So this is to actually enhance the corrosion resistance and give the more durability of the material towards the steel material. Second, in terms of design flexibility, it can be curved, it can be flexibly curved and cantilever, especially on the eave extension and so on. Okay. Third, better space utilization. Better space utilization means you have actually more clear span, okay, less column to be used, less beam to be used, and actually lighter. Fourth will be zero maintenance. You actually, with the current technology now, you actually maintenance free. With colorable material or any other material that you use, now you have those self-cleaning process. Okay. In the material of the steel also actually contributes certain thermal comfort to the home user or to the building owner, such as in daytime you can it absorb heat, and it at the night time actually it release heat faster than the other material. Okay. With current technology, it also contributes certain SRI value, which contribute certain points to the green building requirement. Six will be better in energy efficiency. Okay, reduce energy consumption. Once you release the heat faster in the building, then you will not use a lot of air conditioner. Then you reduce energy on that. Okay. I'm talking about the steel. It can be actually designed for the end of lifespan, which is fully actually recycled. Okay, like for example, like this short video, it shows that okay, concrete actually when you construct, okay, when you want to demolish, it's a bit difficult to demolish and it's a bit difficult to recycle. Okay. Okay, fourth, I'm going to explain about steel application towards the smart city development. This is very important. Okay, with current technology now, latest by engineer design and everything. Okay, we have actually a framing system. Okay, in overseas actually most of the double story or single story building they started to use this lightweight system. We call it as an IBS system, enduro frame. And all this actually using every single column and detailing is actually using every steel material. First of all, why we're going to this direction is actually lighter in construction. You have certain safe costs. When you're building lighter, you save your foundation cost. Then it's actually fully modular and prefab. You have zero wastages. By using the CAD and CAM software, you actually make to a cut dimension with the exact dimension, and you help to reduce certain wastages. Okay, it can be done in single story and multi-story. Okay, and you can easily construct and actually deploy. Okay, so several will be actually flexible wall and floor option. Okay, and the most important thing is actually is termite free and fire resistant. Okay, now I will show you some of the video. Okay, regarding how it construct. You can play the video. Okay, if you look at this video, actually, this building can be constructed within actually a few days only. So it can actually easily be done and it's faster. Okay, you can see less wastages, okay, at the ground, and you need less manpower only. You need about around 10 people or 6 people to actually construct the whole single-story building. Okay, and with the material, you can give a material can last about 25 years corrosion and 10 years color fading. Okay. Okay. In overseas, actually, most of the building they are using this enduro system and will carry as an IBS system. Currently, Malaysia actually starting to adopt it, and some of the school, some of the single-story building, low-cost terrace house, they actually started to use this enduro frame system, or we call it as an IBS system. These are the few examples of project in Australia. They have been using it for 25 years already. Okay. This is also some of the example. Okay. So a lot of people will ask me that by using this IBS system, do you have any problem on the M&E conduit ducting and so on? So there's no problem because based on the software, in design, actually initially they already designed cater for the M&E equipment or M&E trunking to be constructed or to be installed. So already in the system, in the program that we already programmed that. So no problem on that. So you can see that when you prefab it, pre-design it, you actually limit the wastages and you can actually limit it any failure to be any defect. Okay. So another steel construction that we always actually highlighted is our twin tower. The whole building actually is using steel. Okay, only the center part of the building is actually using leaf core, which is the concrete part, which that is the main backbone of the building. Okay, for example, Petronas Tower is actually about 88-story high, and it's actually using composite floor decking, which is the bonded too. Okay, and PMB Tower also the same thing. Okay, they are actually using the structure decking. Okay, let me play a video how this TRX been built and actually how long does it can last. If using the conventional way, I don't think so. Actually, 90 months can be completed. Okay, so it might take more than 90 months because you need to cast the concrete, you need to construct the formwork. So let me show the video. Okay. Okay, by using this decking, structure decking, is the video playing? Okay, by using for this structure decking, you can actually construct the building faster. You can speed up the construction work, and the most important thing actually is how does it speed up the construction work is when you casting your slab that time, you can do all your architecture work below of the the below floor. So let's say for example the 5th floor you are casting the concrete slab. Then the 4th floor there you actually can start your tiling work or your M&E work already. So that's the advantage of using the decking, and it helps to actually speed up the construction faster. And the most important thing actually is lighter, and the foundation will be lesser. For those construction that have soil problem, settlement problem, this will be a good choice or good decision the engineer will use. Because why? It actually lighten up the building. You will not create a heavy load to the building, and your soil actually, the ground actually can cater for that weight of the building. So this is the thing. So you can be this building actually constructed in 19 months only for 106-story high of a building. So it's actually about 95 story and 446 meter. Okay, one floor you can one floor of casting you can construct within 3 days. So you can imagine you can do a lot of architecture work below of the below floor when you're casting your slab. Okay. 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 In this area, actually, we are moving to this direction, and I can say that actually, we actually moving in this green direction. When we are moving this green direction, okay, software that we use also is of the requirement. So you can see here actually, BIM is one of the requirement. You can play the video. What is BIM? BIM actually is a building integrated modeling. Okay, so BIM actually connect the team or workflow together, and all the data you can share among all the consultants. So the reason why using BIM actually is a life cycle of a building in infrastructure, from the design stage to the construction stage and to the operation stage. In BIM, actually, you actually can have a hassle-free. Why I say hassle-free is that actually you can actually share your data among each other. It doesn't need to print out the drawing, and it doesn't need to print out anything to share to the other consultant. You actually can upload to the cloud, and actually every of the consultant can download it from the cloud and can make amendment at the BIM. So when they make amendment at the BIM, any amendment like SME, there's a crash detailing problem. Then once they meet they edit it. Once they edit it, they actually the other consultant can share among it. So that's why we are going to this direction. So actually, BIM is part of the integrated, I would say, software that actually hassle-free. One thing. Second thing, once you want to trace back the drawing, it's very difficult to trace back the hard copy or soft copy. So by using BIM, you can actually just click by a click from version 1 to version 5. You know pages of your drawing already. Okay. Okay. Moving towards solar direction. So I would say that metal sheet, okay, or steel sheet actually is one of the profile that can collect more rainwater. Okay, you actually direct a channel back to the gutter, and you can actually collect. You can actually use it clamping for the solar. Okay, so as a solar metal roof, because of low pitch, okay, you can actually collect more energy efficiency for the solar. Okay, by using the solar panel, okay, you actually have a clamp to clamp it onto the metal sheet. Okay, so rainwater harvesting is one of the direction. Metal sheet is one of the profile that can actually collect rainwater, and it helps to generate. Okay, not generate. It helps to actually channel back the water to the gutter. More efficiency. Okay. So green roof also one of it. You can actually the profile itself can help to actually plant certain grass, okay, green element on top, and it help to actually drain out the water. We have the artificial grass or real grass also. Okay. Okay. To sum up the everything, I would say that still build towards the sustainable building, and it helps to actually create a better lifespan efficiency. Okay, and it's one of the material that recycle efficiency. So for future, we're actually going for this rainwater harvesting, green roof, and solar roof also. So that's the end my sharing. So I'll pass back the time to the moderator.
Thank you very much for the very informative talk, Mr. James. I would like to open the session for question and answer. You may chat in. You may put in your question in the chat box below. While the participants are putting in their questions in the chat box, Mr. James, may I ask you a question? How do you see the cost comparison between the IBS system that Lysat have and with comparing it to the conventional concrete constructions in Malaysia?
Okay, first of all, the IBS system that we have actually, we are actually studying, okay, how it can save even more cost on that. First thing is actually it's lighter, and how to actually cantilever further apart more and more so that you have a better clear span, and you have it. I mean, most of the designer would not like to have most of the column, so we're actually looking at that now, and it definitely saves some certain cost, and it actually contributes certain points on the IBS system. Yeah.
And you mentioned that your company is actually going towards or probably have established in the BIM, yeah? So I believe all your products are in a BIM ready component for designers to choose from.
Yes, all our product, including our profile, including our trusses, our even though Enduro frame, we actually going toward this BIM direction, and we have our BIM object anytime ready for the consultant and designer. Anytime they can download it from our website or request it from our person, or you can actually call me up and I will send it to you, the object. Come to a certain extent, let's say you need us to actually help on detailing, especially on the facial part or whatever detail that you need, we're able to use Revit to generate the detailing for you.
Yes, that would be really great news for our participants. I have another question here from Mr. James from JKR, from Sanisa to Mr. James, okay, from JKR. How your product can cope with low pitch roof, for instance, flat roof, with the problems of bonding, I guess, or leaking?
Okay. Each our profile, there's a certain recommendation on the pitch. Some actually can be done in 2 degree, 3 degree, 4 degree, and 5 degree. Of course, in one of our profile, especially the KIP system, okay, we only recommend 2 degree pitch. Some designer actually they prefer go to 1 degree. The reason why we don't go so low, the gradient, is because Malaysia tends to have this thermal expansion and contraction. The structure tend to have certain deflection. So that's why the 1 degree will actually to save on the deflection. I'm sure engineer design on every of the trusses design, they cater all the design or structure design, they cater certain tolerance or percentage for the deflection of the steel. So metal roofing also is the same thing, or any steel is the same thing, because steel is the second highest expansion and construction it happens beside aluminium. So basically you need to cater for that. So 2 degree is the lowest, is the better, so that you will not have any water ponding. And especially the profile of the rib height, the height of the profile, it actually makes the difference. Because if you choose the lower profile, you have a chances of water ponding actually will overflow to the side epic. So choosing the higher profile is better if you have a very long length of roof. Yeah.
Okay, that's the question from Ms. Anissa Sulaiman, yeah, from JKR. Another question from me. You mentioned just now that steel can be recycled, and we know that for a very long time that it is very profitable business to actually recycle steel, and it has been highly recycled. Can we hear from you how Lysat approach the recycling of steel?
Okay. Recycle of steel actually we actually go back to the raw material steel supplier. Okay. Normally our part actually we actually some of the steel we will say that we can be done like they melted back, actually they actually form it back in a flat sheet form. So for further more detail, we will need to actually go into that, and maybe we can give you more information after we have more data on that. Okay.
Just now, you have mentioned that we can actually construct the building within very short time. Could you give us a time frame for probably a 2-story house?
Okay, by using steel.
How fast?
Okay. It depends how complicated is the design. Okay, it depends on the requirement of the building or the house. Okay, but normally for single-story house, it can be constructed using steel, or the steel framing up is about around, I would say about around 15 to 20 days. Yeah, all the steel construction be up. Yeah. So the main point is actually when construct a high-rise building, especially when you want to construct a high-rise building, the normal conventional way actually you start to construct your formwork first, timber formwork. Then after that you put in your rebar, and then you put in your actually you pour your concrete and wait for the casting of the concrete. The most important thing actually the casting of the concrete that and the formwork that constructed. So actually will drag time. So for high-rise building, steel construction is the best choice that you can actually help to cut down the construction time, and less when you use steel, actually less manpower to be used. Yeah.
So you can actually get a house within 15 to 20 days. So that sounds really great. But do you know that any building that have been built, what is the performance of the building?
Okay. So some of the residential or some of the school that using this andro frame or this steel construction up actually has been built, especially in Sabah. Okay, and some of it in Klang. Okay. So basically, I would say that the time frame of the building actually depends on the material, one thing. So with the some people might worry that actually by using steel will it collapse or not? So based on the engineering calculation, we really cater all these safety factors and all these loading defects and to design for a 2-story or 3-story building using steel construction. So that's why our R&D department we're going towards another level, which is try to use steel construction in 5 to 6-story building. Yeah, we are doing R&D on that. But for 2 to 3-story, it definitely is not a problem already. Yeah.
It's really good to hear that your R&D team, is actually pushing towards cost efficiency and also fast building. So that is really great. Okay, I do not see any more questions from the participants. Thank you very much, Mr. James, for sharing your vast experience with us today. Before we end today's webinar, I would like to request that all of our participants to fill up a survey form that will be attached in an email following up to this pocket talk. And we would like to promote Malaysia Green Building Council's upcoming events in August. On 25th August, which is tomorrow, 2 to 6 p.m., we have a webinar, Building Out Waste, Transforming Waste in Construction and Demolition. And on the 28th of August, 9 a.m. to 1 p.m., we have Academic Research Collaboration Reactor Program, which is called the ARC Reactor 2021. Thank you, Mr. James.